Here we have the quotient function f divided by g of x. It's just f of x divided by g of x, which in our problem now would be 5x plus 3 divided by x minus 4. Now this is the first of the problems in which we'd have to worry a little bit about the domain, because the domain of f and the domain of g have no restrictions on them whatsoever. They are all real numbers. But the domain of the quotient function has a problem if x equals 4. So in this case, the domain now of our combined function is any x not equal to 4. So sometimes we have to pay attention to how the domains might change when we're performing these operations. Let's look next at a couple of different functions. F of x equals the square root of x plus 2. And g of x equals x squared. Then let's consider what we'd have if we were looking for f plus g of 3. If we were looking for f plus g of 3, that would give us the square root of 3 plus 2 plus 3 squared. So we'd have the square root of 5 plus 9. Irrational. And one of the things we'd have to be careful of in this problem is that the original domain of f was not all real numbers. So we'd have to be careful that we were staying within that framework. Is 3 an acceptable value? Sure, but what if I had asked for negative 3? If I had asked for negative 3, then I would have had a non-real number here. I would have had the square root of negative 1. So we have to understand from the beginning that we must stay in the domain of f and g, the combined domain of f and g, in order to appropriately do these arithmetic operations.